In this video, I'll show you how to use containerized MySQL and PostgreSQL using Docker and Docker Compose in development environment. So I'm using macOS and I already have Docker, which is Docker for Mac, which is already installed. Take a look at the description for the links and references of the softwares that I'm using. Let's quickly take a look at the steps that we are going to go through in this video. We are going to start by creating a Docker Compose file, which is a YAML file, and define a service definition for MySQL container. And then run MySQL container and test a few different ways of accessing the database running in that container. Next, we will see how easy it is to run multiple MySQL servers of different versions in parallel using Docker. And then we will learn how to edit or modify the configurations of the MySQL server that is running inside the containers. Next, we will see how to share the data directory between the host operating system, which in my case is macOS, and MySQL server that is running as container. And then add a new service for an admin web tool to run as a container, using which we can access and manage the databases running on containers. And lastly, we define a new service for PostgreSQL container and run and test. So let's get started. We need Docker image for MySQL to start with, and we can find the Docker images on either Docker Hub or Docker Store. Let's go to Docker Store, which is store.docker.com, and search for MySQL. Or you may also go to Docker Hub, which is hub.docker.com. There are a few different Docker images listed for MySQL server. Look for the one published by Docker. Click and view the image detail page. And here there are a few different versions of the image available for MySQL. And there are some instructions on how to spin up a container using this image. Now, you may pick any of the versions of MySQL image, and that really depends on if you're looking to set up a specific version of MySQL for your application or just want to test things on a latest version of MySQL or on a specific version. Most of the instructions and documentation in here will guide you through how to run and configure MySQL container using Docker command. So I find it easier to work with Docker Compose instead to define the configuration and run containers. Let's create a Docker Compose YAML file to define MySQL container service. Go to projects directory and create a new directory. And I'll name this directory as db on docker and go into that directory. Let's open that directory in a code editor, and we have an empty directory opened up in here. Now I will create a Docker Compose file. Now let's start with Compose version, which I'll set to 3. Now define services, and this is basically where we define the container definitions. The first one will be MySQL, and I'll name the service as MySQL dev, and this service will use the MySQL image from Docker Hub or Docker Store, which is the default registry for images. So let's pick the version 802 or 8.0.2 of the MySQL image, which also maps to the MySQL version it's going to run. Now, we need to provide some root password and database schema names to be created. As per the documentation of this image, there are a bunch of environment variables we could use to set those up. In the Compose file, under MySQL dev service, add a property called environment, which takes a key value pair or a list of key value pairs, and those will then be passed into the container as environment variables, and the server that run in the container will use those environment variables to set up the root password and database. Let's set MySQL root password as password. I will set MySQL database name as blog app. Now these two environment variables should be good enough to start with. When we run the service, or when it is run as a container, MySQL listens on port 3306 or 3306, but port is container specific and it will not be available on the host. And that means if you would like to connect to MySQL using a MySQL client installed on your host OS or Mac OS, you cannot do so using localhost or 127.0.0.1 on that port 3306. For us to be able to connect to MySQL running in a container from the host OS, we will need to map the container port onto an available port on the host operating system. So for that, we could use the service property called ports, add ports property for MySQL dev, which takes an array of port mappings. I will map 3306 of container to a port, which is 3308 on the host. With this, when the container is running, you should be able to access MySQL from the host OS on localhost or 127.0.0.1 at port number 3308. That's the basic definition of MySQL service to be run as container. As I mentioned before, we will be using Docker Compose command, which will use Docker Compose YAML file in the current working directory to run the defined service containers. The short command is Docker Compose up. Now this will create a sort of a virtual network for all the containers or services defined in the compose file. For now, we just have one service and it created a network, and the services part of that network started pulling the MySQL Docker image from the Docker Hub or Docker store. And once the image is downloaded, it will start up the MySQL server in the container. Now it started up MySQL server and it is listening on port 3306 in the container, which should be available for us on port 3308 on the host. And there are a few warnings which we can ignore for now. And now that MySQL is running in a container, let's view the service or container status. On another terminal window, go to the project directory where the Docker Compose YAML file is defined and run Docker Compose ps. And that listed one service that is configured and running. The container name is db on docker, which is the name of the directory without the hyphens, underscore MySQL dev, which is the name of the service, underscore 1. One can run multiple instances of the service, in which case the container name will have a different suffix. For example, db on docker underscore MySQL dev underscore 2. The command executed in the container to run MySQL server is docker entry point.sh. Now this script is defined in the Docker image of MySQL, and let's not worry about what's in that script. State of the container is up, which is running. The container port is 3306 and mapped to host port 3308. Let's test accessing the MySQL using a MySQL client. Here I have MySQL Workbench, which is running on Mac OS or the Docker host. Create a new connection, give it a name. I will name it as MySQL dev. Host name will be localhost or 127.0.0.1. Port number is 3308. Username is root. Default schema is blog app. Submit and the connection profile is created now. Let's double click to open the connection, which prompts for the root password. Use the password as configured in the compose file. Paste that in, submit. Connection is successful. Here is the blog app database, but there are no tables yet as we don't have anything created. Let's quickly create a table with a couple of columns and insert a few records. I will name the table as posts and add 2 columns, integer ID and varchar title. And here is the create table statement, submit, and that created a new table. Let's browse the data in that table. No data yet. Create a few post records, post 1 and post 2. And we have 2 records inserted in the table. Now it all looks good accessing and querying using Workbench or using any database or MySQL client. Let's stop the container. Container has been stopped. Now let's see another way to connect to the same database. Now this particular one isn't a good way to connect to MySQL running in a container, but one of the ways I just wanted to show which might be useful in some use cases. I will create a new service and name it as client, but use the same MySQL image. This service will depend on MySQL dev service so that when the services run, it will expect the MySQL dev service also be running. And the command to run in the container will be different than the one used for MySQL dev, which is the default one. And the command in this case will be MySQL, the client, using root user as configured in MySQL dev definition, and password is password. And the host, where we need to mention the host name or the IP address of the MySQL server. But the shortcut in Docker Compose is that you can use the service name as a host name. In this case, the service name of the MySQL service is MySQL dev, and then the database name, which is blog app. As I mentioned before, there's a default network created for all the services defined in the compose file. This new service will be added to the same network, and the services can use each other's service names as a host name. Also, there are ways you could give it an alias if you don't prefer to use the service name itself, but the service name works in most cases. Start the services up. Notice only the MySQL dev will continue to run, but the client will exit as it doesn't need to run as a daemon or a service. Let's check the services status, and there are 2 containers created, but only the MySQL dev is running. Client is exited with status 0, which is good. Let's verify the connection to MySQL dev one more time using Workbench, and it looks good. Let's go to the terminal window and connect to the same database using the new service we created. And the command will be Docker Compose run, the name of the service, which is client. And it gives MySQL client prompt, and that is because the command used in the service definition for the client is MySQL client command to connect to the MySQL dev service. Notice this is a separate container instance connected to MySQL server on the MySQL dev container using MySQL client command. And there were already 2 containers. One was MySQL dev's container instance, and there was one more client instance which exited with status 0, and this is the third one. And also notice the remove option, RM option, will ensure the container is deleted on exiting out of the MySQL prompt. Now, let's not go into the details of that, which is out of the scope of this video. Let's quickly verify that it's successfully connected to the same database, show tables and select all the post records, and that looks good. As I mentioned, this may not be a good option, but I just wanted to show this approach which might be useful just to play around or some use cases. Here is another method to access the MySQL database running in a container. Instead of spinning up a new service and container, you can execute a MySQL client command in the same container, which is this one here, or the MySQL dev container that runs MySQL server. And this way you will not need a new service, and also that Docker will not create a new container. And the command with Docker Compose is Docker Compose exec MySQL dev, basically running the command inside MySQL dev container, and the command to run in the container, which is MySQL user as root, password as password, and the database name, which is blog app. Now you don't need to mention the database host name, as this command is executed in the same container where MySQL server daemon is running, and also that it will connect to the MySQL server over default connection socket in that container. Now this is similar to running a MySQL server on the host OS and also a client on the same host, where I don't need to specify the host name to connect to. The connection is successful. Let's show the tables, query some records. That all looks good. Now that we have one MySQL server running in a container, let's see how we can run another MySQL server. This will be useful if you need to run multiple versions of MySQL servers of different versions on the same machine. Let's say you work on a new application that uses the latest version of databases, but you also need to support and maintain an older application that uses a slightly older version of MySQL. Now let's define a new service, name it as MySQL Legacy. Let's say we're going to use this for a slightly older version of MySQL. Image will be the same, MySQL. Let's pick 5.7. Let's configure this with the root password and database name. I'll paste in those from MySQL dev service. I'll modify the database name as legacy app. The MySQL on this service or the container runs on 3306. Let's map that to 3309 on the host. Remember, we have used 3308 on host for MySQL dev service, so we have to pick a different port number on the host for this particular container service. Now that's it. The new service for MySQL Legacy is defined. Now let's move the client service below and comment that out. We're not going to be using that from here on. Back to the terminal window, let's stop the services and start both services up. A few seconds fast forward. Let's check the status. There are two containers running now, one for the MySQL dev service and the other one is for MySQL Legacy service. The MySQL server instances are listening on 3306 on both containers, but mapped to a different ports on the host. Now let's test the connection on MySQL server on MySQL Legacy. The command is Docker Compose exec MySQL Legacy, and the MySQL command, which is MySQL using root user, password is password, and the database is legacy app. And that looks good. There are no tables as we don't have anything created yet, but the connection looks good. Now let's exit out of the MySQL prompt and test the connection to the server on MySQL dev container. And the command is Docker Compose exec MySQL dev, and the MySQL command, which is MySQL using root user, password is password, and the database name is blog app. Connection is successful, and there is posts table that we created earlier. Now here we have two databases running and as two different services in two different containers, and we were able to connect and access the database successfully. Let's exit from this container and test the connection on MySQL Workbench by connecting on the host ports. Connection profile for MySQL dev is already created. Let's create one for MySQL Legacy. I'll name the connection as MySQL Legacy and the port is 3309. Leave the rest default and submit. Connection profile is created. Let's connect. The root password is password and submit. Connection is successful. Here is legacy app database. Now let's connect to MySQL dev, which was configured to connect to port 3308. And the connection looks good. And the blog app database has posts table. Everything looks good. So this is good. We were able to run two different versions of MySQL servers as containers in the same host machine without having to worry about version conflicts and installation challenges. Now let's go to the next step and learn how to modify the MySQL server configuration. In a regular MySQL installation setup, you would modify /etc/mysql/my.cnf file on the host or provide a custom configuration in /etc/mysql/conf.d/config file.cnf file. Now the default config files are in the MySQL Docker image, which is predefined, and we cannot edit those files in the image, but we have a couple of different options to supply custom configurations to it. The first one is to create a custom configuration file and put it on the host machine and mount the volume or the path on the host machine to the file path on container. The second option is really to build a completely new image from the base image as the MySQL image and then override the files and then build the image and use that image. We're going to be looking into option 1, in which we are going to be creating a custom configuration for MySQL and supply that using volume mount to the container. Create a new file and name it as my.cnf. Now let me paste in some configuration here. Basically, this is the configuration for MySQL D, the server daemon. There are a bunch of different configuration options that you might want to play with, but I don't want to go into the details of those here. This is just to show how one can supply custom server configuration when running with Docker. Back to the Docker Compose file, under MySQL dev service, define volumes, which takes an array of volumes. Let's mount my.conf, which is in the current directory on host, hence /my.conf to /etc/mysql/conf.d/config file.cnf on the container. Now when we run the service or container, MySQL will pick the custom config /etc/mysql/conf.d/config file.cnf file, which the container has mapped to my.conf on the host. If you need to make changes to the config, you would need to modify this config file on the host and restart the service again. Back to the terminal, check the status of the services. Both containers are stopped. Let's delete both the containers so that we do a clean start again. The command is docker compose remove, confirm, and it deleted both the containers. Let's start them back up, and this time the MySQL dev service container will use the custom server config combined with the default my.cnf. If it fails to use the new config, you will see errors, but there are no errors. That means it started up without any trouble. So I'm not going to test the behavior of MySQL server on new config change, but it looks good. But if you're curious about it, you might want to connect to the database and query the server configurations and test it out. But let's connect and test the access. Connect to MySQL dev container using Docker Compose exec. Connection is successful. Query the tables, but there are no tables. The previously created tables are gone. That is because we deleted the containers, which also deleted all the data associated with those containers. Now we can solve that problem by storing the MySQL data on the host file system instead of the container. I will create a directory to store the data for MySQL dev service. Name the directory as data. Let's verify the container status and delete both the containers one more time. Now we need to mount the data directory in the host, the current directory, to the MySQL data directory. Check the documentation for the data directory path of MySQL on container. Here is the default data directory path /var/lib/MySQL. Now back to the compose file, mount ./data on the host to /var/lib/MySQL on container. And this volume will have read and write permissions so that the container can write to this directory. Back to the terminal again. Let's start just the MySQL dev service now. While MySQL server is starting up, it created a bunch of files and directories inside the data directory on the host. Now that means MySQL running in the container using the data directory we mounted to store the data. Now it started up. Let's connect to it using MySQL Workbench. Here it is. Create table, posts, and add a couple of columns. Submit, insert a few records, and save. That's good. Let's stop the container. Looks like it failed to stop, but you can stop the service using Docker Compose stop command as well. Once stopped, let's delete the containers one more time. It has been deleted now. Verify there are no containers running. Let's start the container again, but before we do so, verify the data directory still has the data that was created before. It looks good. Start the container again now. Let's connect and verify the database, and the data is not lost. Connection looks good. Query posts table, and it looks good too. That means even if you delete the container, you'll not lose the data because the data is stored in the host file system. Let's exit from the MySQL prompt. Now let's take a look at a handy web tool to access the databases running in containers. The name of the tool is called Adminer, a PHP-based tool. The image name is Adminer. Search on Docker Store or Docker Hub. Here it is. Go to the detail view page and scroll down to the Docker Compose section. Here is a sample Docker Compose YAML service definition. Very easy and straightforward to set up. Let's create a similar one in our compose file. Back to the compose file, add a new service. I'll name this service as admin. Use the image Adminer. Adminer runs on port 8080 in the container. Let's map to the same port on the host as well so that we can access the web UI on the host in the browser. That looks good. We have 2 MySQL services, and the third one is for the web tool using which we can connect to those servers on browser. Back to the terminal window, stop MySQL service and run Docker Compose up again, which should start containers for all the 3 services. Verify the services status, and we have 3 service containers running, 2 containers for the databases, and an admin tool which is available on port 8080. Go to the browser window and go to localhost 8080, and here is the admin UI. Let's connect to the MySQL on MySQL dev container. The system is MySQL, server is the host name, so this will be the service name, which is MySQL dev. You cannot do localhost or 127.0.0.1, as that would mean localhost within the container running admin or app. Because admin and MySQL dev services containers are on the same container network, admin container can use service name MySQL dev as the host name to connect to MySQL service on that container. Username is root, password is password, and the database name is blog app. Submit, and it's successfully connected, and we are able to browse the database, table, and data. One can create table, insert, and manage the data using this tool. Now on a new browser tab, let's connect to the database running on the other container, which is MySQL Legacy. System is MySQL, server is the host name, which is the service name MySQL Legacy, and username is root, password is password, database is legacy app. Submit, and successfully connected. Now back to the terminal. Once again, let's stop all the containers and verify the status is nothing running. Now let's add one more database, and this time let's set up PostgreSQL database alongside MySQL and the admin tool. So in the Docker Compose file, I'll paste in some code. Now this is a basic definition of the service for PostgreSQL container. You might want to go to the Docker Hub or Docker Store, and you will find the instructions on how to use this image. It's very similar to MySQL image. PostgreSQL also takes some database configurations using environment variables. Here is how we have configured it. So I have named this service as pgdb, and that uses Postgres image. The user is root, password is password, and the database name is blog app. Back to the terminal window and start up all the service containers once again. Verify the status on another terminal window, and we have 4 containers running. Notice the Postgres container does not have a host port mapped, and hence cannot be accessed from the host, but can be accessed by the other containers or services defined in the same compose file that are within the same container network. In this case, admin container can access Postgres container using pgdb as the host name. Now go to the browser window, access admin tool on localhost 8080. System now is PostgreSQL. Server is the host name, which is the service name, and that is pgdb. User is root, password is password. Database name is blog app. Submit, and the connection to the database Postgres looks good. Let's create a table with a couple of columns. Posts is the table name which has been created. Let's also verify that by connecting to the Postgres database on terminal window by accessing the Postgres command line interface from within the container where Postgres is running. And the command is Docker Compose exec pgdb, and the Postgres command, which is psql using root, and the name of the database is blog app. Prompts for a root password, type that in and hit enter. That's successfully connected to PostgreSQL database. Like with MySQL, there are also multiple ways one can connect to the Postgres database running in a container. Now that was a quick walkthrough of creating, running, and managing multiple versions and types of database servers in a local development environment using Docker and Docker Compose. Now that's it for this video. Thanks for watching.